Yeah, good evening everyone. I am Ashwini and we will begin this session right now. I hope everybody can hear Akansha, Prashad, Swati and Varsha. Am I audible to everyone? So let's begin the session. Let me first talk about the session, that is the course of the statistics which we are going to begin with, and then we will start with the first session. Okay, so first let's talk about Edumanta. So Edumanta is an online education portal which provides live courses on different subjects, and you can see all the subjects listed on edumanta.com. Talking about the course Statistics for Professionals, we are going to cover the basic and advanced statistics as well. And most of the analysis in this course we are going to do on Excel. For advanced tools like R or Python, there are different courses on which you can learn this statistic as well. So this is very basic statistics, I mean to say, in terms of tools, but yeah, it will also cover the advanced topics. So let's see what we are going to cover in this course. So the first session, that is today, we are going to cover the descriptive statistics. In this session, we will going to cover the basic terminologies related to the statistics and also the descriptive statistics. For example, when we see a set of data, for example, I have pulled out this data for a share for last 1 year, that is from 27th of August 2018 to 27th of August 2019. So this data contains 250 observations. So when I am going to tell you that see this data and tell me something about this, just by seeing this data you won't be able to tell me anything. But by calculating few things or presenting this data in form of charts, graphs, tables, you can derive some information about the characteristic of this data. So basically, that's what called descriptive statistics. That is, tell us about the characteristic of the data. Okay. And in further session, we will look for inferential statistics. So basically, once we understand that what is data we are having, what is the characteristic of data, then after knowing the data, whether it is normally distributed, exponentially distributed, so we understand what is distribution. But after understanding the characteristic of data, we will make some model, okay, statistical model, which we will learn further. So on basis of that model, we will forecast. For example, I have the stock price for last 1 year, and now with help of that stock price and analyzing the trend and applying some model, maybe a regression model, and come up with the price for tomorrow. Okay, so tomorrow price I don't know right now. So this statistic modeling will give us a estimation about tomorrow price. That may be true, that may be exact, or maybe not. But we try to estimate, and that's what called inferential statistics. So as I told that we will begin with the descriptive statistics, which will basically going to contain the measure of central tendency, which will constitute the calculation of mean, median, mode, quartile, and interpretation of all these terms. And then we will look for dispersion. What is dispersion and how we calculate it? So basically it's range, mid-range, standard deviation, interdecile range, interquartile range. Basically, these are the measures of dispersion. And finally, in descriptive statistics, we are going to look the skewness and interquartile. That is also a kind of dispersion measure. Well, after that, not in this session, but in the next session, we will look into the probability, in which we will cover the concepts of basic probability and then application and conditional, and in this way we will move to probability and then probability distribution. Okay, like what is binomial distribution, the normal distribution, exponential distribution. But our course will be more focused towards normal distribution, because in statistics we always assume that data are mostly normally distributed, because that helps us to get the estimation. So based on the assumption that data whatever we are using is normally distributed, will help us to make estimation. And after that we will learn about forecasting models, right? Yeah, statistical interference. So basically in this we will study about hypothesis testing, how to make a hypothesis, how to see that whether the hypothesis is relevant or not, are we getting significant digits for the proving that yes, the hypothesis we are testing is something which is right. And then we will look for other like regression, ANOVA, and all these kind of different models we will work on. And then finally forecasting. After making a model, we need to do the forecasting, and that we will use for regression again, then time series. So basically we are going to use these things for modeling and the forecasting part. So this is going to be the whole course structure, and this will be covered in the 10 sessions. So today the first session is going to start, and going to go over the first session. Yeah. So basically I told you that this is going to be of 10 sessions, and if any doubt in between, you can simply unmute your call and ask me questions wherever you want clarification, or after the session also we will have 10-15 minutes where you can ask your confusion. So let's come to first question, that what is statistics? As I told you that we will be having data for anything like inflation for last number of years, stock price for number of years, indexes for number of years. So just having that data base is not a statistic, right? So we need to put those data into a presentable form, into a form by which we can derive some information about the data. We can see the trend, right? So we can see that okay, GDP is going up from last 5 years. It's maybe right now in this recent quarter the GDP is the lowest of all last 5-6 years. So for the latest news we just read that the GDP rate is 5% for April-June quarter. So these are basically data, okay, that are presented in such a way that convey a meaningful message. So let's discuss few basic terminology of the statistics. So the first one is population. When we talk about population, a very simple example is say the population of India, that's 130 crore, right? So if I am a researcher and want to conduct a research, say based on the eating habits of the people in India, okay. So if I am going to take the survey of just 130 crore people in India, then that will be very, very cumbersome as well as costly and time taking, right? So to avoid these things, these problems, we come up with samples. So instead of surveying the whole population, what we do, we pick up the sample, maybe sample consisting of 100 people, 200 people from different geographical area, and then based on the observation from those samples, we can conduct our research. So yeah, so but for population, a survey is always done, say a census, which is being conducted at every 10 years. But it's not always possible for every researcher to just to conduct a research. We can go and take a survey of population, so we come up with a sample. Okay, population is not only come of the Indian or India or any other country number of person living. It can be number of car in a country. So that is also part of population. And if we want to calculate the average speed of the car in India, then it's not necessarily we are going to conduct the survey of each and every car. We can just select some sample and then calculate the average. Okay, then let's talk about parameter. So when we conduct a research, we have something in mind that what conclusion we want or what is our goal. Okay, to reach that goal, we need to put some questions. Okay, for example, if I want to conduct average height of the person or population of India, then we need to know that I need to record the average height of every person in India, maybe male, female. So these are the parameters. So talking in terms of drawing a circle. Suppose I'm just going to tell that okay, I want the circle to be drawn on the screen. Then I'm just bringing out the board. Yeah, so I is saying that I want a circle to be drawn on this screen. So there can be number of circles which I can draw over here. Okay, but if I'm going to tell you that okay, this is the center and on this center I want a circle. So basically you can draw a number of concentric circle over here, right? So again, giving just a center, the information of the center, we cannot say what kind of circle do we want. So if I'm also going to give you say just not the center but a radius, then again you can draw a number of circles with the same radius. But if I'm going to give you a center and then a radius, then basically you can just come up with the one specific circle. So in this example, the parameter is center and the radius. In the same way, when we conduct research, what are the observation we need to take to make a conclusion? So that is basically the parameter. So we already discussed what is census and what is sample. So now we will discuss about the kind of sample, but before that, let's see what is discrete and continuous variable, because that's important in terms of statistics. When we talk about discrete variable, it's basically the whole number. For example, if you're going to count something, say number of students in the class, so your reply will be 10, 11, 12. That would be simply a whole number, right? It cannot be a fraction. So these kind of numbers are basically known as discrete variable, whereas continuous variable, for example, length, weight, which can be broken down into fractions. So these kind of data like weight 5.5 feet, 5.7 feet, 6.2 feet. So these are basically the example of continuous variable. And then we will come to data collection. So in a statistic, there are two ways by which we can collect data for the research. So one is primary data. So primary data is basically we are getting directly from the source of the data. For example, if I want data for some company, financial data, so I may go to company's website and then pull out its annual report, and from there I can pull out the financial data, or maybe go to the manager of the company, CFO of the company, and actually interview him, and then we can get the data. So these are basically known as primary data. But instead, if I am going to some analyst or some other financial company, institution, and from there I will be getting the data, or maybe I will go to some third party website from where I can just say money control. So from there I can pull out the data, or maybe some social media. and get the information about some person, company. So these kind of sources are known as secondary sources, and the data collected from here is a secondary data. So let's talk about the sampling technique. So basically, there are two kind of sampling techniques, and one is probability sampling and non-probability sampling. So in probability sampling, for example, I'm in a school and I want to conduct a research on class 10 students. So I directly went to the class 10 students, in this class of 10 students, and then I pick up, suppose there are 100 students, and I'm just going to pick up 10. So it's like just closing my eyes and picking any 10 of them, okay, randomly. So in this case, every 100 students will have equal opportunity to picked up in the sample of 10 students, right? So the probability sampling is simply every member of the population has equal probability to get selected in the sample. So that's what called probability sampling. And non-probability sampling is exactly opposite to that. For example, if I want to conduct a survey of any kind, and just for convenience, I'm selecting my friend for observation from them. Instead of going to public and then asking the questions, I'm directly asking them to friends. So I'm biased towards certain people. Okay. So these are non-probability sampling. That is, every member of the population do not have equal probability of getting selected. So now it's about random sampling, basically of two types. One is simple random sampling and a stratified sampling. So I explained that if I'm going to class 10 students and then selecting them randomly, so that's called simple random sampling. But in another case, if I'm going to same class and then dividing the whole class into two groups, girls and boys, and then picking, say I want 5 girls and 5 boys, so dividing them into two groups and then doing random sampling or simple random sampling from each group. So this fundamental of grouping is called a stratified sampling. So we are actually dividing the population in groups, and then from each group we are doing simple random sampling. I hope it is clear what is the difference between simple random sampling and stratified sampling. Well, let's come to distribution now. So there are different kind of distribution. So what is distribution first thing? Yeah. So if I am going to say I just want, let's say that I want I took an exam in a class, and the total marks of the exam is 10. So basically what I am going to do, I'm just going to list the number of the students adjacent to the mark. So basically this number of students getting 1 mark out of 10, say they are 3, and number of students getting 2 marks are 5, 3 marks 8, 4 marks 16, 5 marks 19, 6 marks 21, 7 marks 12, and then 7, 5 and 1. So basically what does it mean that, so this is the mark and this is the frequency. Okay, so if I am going to put them in a kind of bar graph, okay, so histogram. So this is not the method to create histogram. I will show you how we are exactly going to create histogram. But for example, I am showing you this graph. So see, this is the kind of graph. we are getting. So this frequency actually shows the kind of distribution. So we saw here that 1 mark the number of students getting 1 mark is low, number of students getting 10 marks is also low, and somewhere number 6 number, the number of students getting 6 is the highest. So this is somewhere near to normal distribution. Okay, so normal distribution is like a symmetric distribution. So if I am going to put something like this, and if this is the mean of that data, okay, in the center, and if I am going to draw a line from here, so the data right to it and left to it is going to be exactly symmetrical. The shape of the distribution is exactly symmetrical. So this type of data is called symmetrical data or normal distribution. Then there are skewed data. So basically, if I am going to put something like this kind of data, so this kind of data is, you can see that the tail is shifted towards the right. Okay, so this kind of data is called positively skewed data or right skewed data. And the same time, if the tail is towards the left, then it is called left skewed data. So what does it mean? Suppose if I am going to draw data or distribution of people or population, height in India. Okay, so we find that the height of people in India is normally distributed. That is the mean height, that is average height of Indian population is say 5.5. Okay, and over here somewhere we will get that this is 4.5. So most of the population, say 99% of the population of India falls between the height of 4.5 feet to 6.5 feet. Okay, but say some other country, maybe they would be having distribution of this kind. Okay, so we can see that here it is the left tail. So what does it say? That the mean height of here maybe say 5.4 of this country. Okay, and the maximum height people, not maximum, say this is 6.5, and then here it is like 2.5. So it means that the height of people, less than 4.5 in this country are a significant number, a good number. That's why even this here, it is a fat tail. Okay, in India we have this say 4.5, and then after that person having height less than this is a very negligible number. Okay, but in this country, the person having height less than 4.5, up to 2.5 also, the number of people of this height are of significant numbers. Okay, large number of people are over there and of this height. So that's what distribution actually shows. So skewed data, so this is negatively skewed or left skewed data in which negative number or lower number or low height people are more in this country. If I am going to talk about positively skewed, it means that in this country, say 7.5 height people are in significant number. So this is what the tail represents, and towards which side it is skewed, either right or left. Accordingly, it is named. Let's talk about mode now. So what is mode? So we can see that here, in every distribution we made, there is only one peak. It means that a person of exactly one height, say 5.5, okay, that is the average height. So this person having 5.5 are in maximum number because they have the highest frequency. So number of people are highest of 5.5 peak. Okay, so it means that this data have only one mode. So mode is basically the observation which will be having highest frequency. Okay, so this kind of data is called unimodule. If there is double peak, for example, if I am going to draw data of this kind, so here it is double peak, maybe person having 5 feet and 6 feet are in very large number. So in this data there is 2 feet, 2 modes, so this is bimodal, and in the same if having multiple modes, then multimodal distribution it is going to be. And finally J-shaped. So J-shaped is something like this. It is reducing, okay, towards right. So this kind of distribution we will read about it. So this is exponential distribution. And finally uniform distribution is a straight line. So basically every member of the every observation have the same number of frequency. So basically this is going to be the uniform or regular distribution. Okay, so now let's talk about measure of central tendency. So I show you that so I show you this data, right? So I ask you that what you can tell me by seeing this data. So definitely you won't be able to tell me simply by seeing at this data. But if you can calculate few things like mean of the data, okay, so we can know that okay, so this is 356, right? So we can say that okay, the average price around for the last year, the shares average price was around 356. It may have gone somewhere around 346, 340, but it can come as low as say 250. So you can get the idea that okay, what is the average, and then you can identify the nature some part of data. Okay, that data is going to be around this value only. Okay, so just to understand how mean sometimes can be misleading, I'm just saying that in Reliance Industries there are 100 employees and they are getting an average salary of 1.5. Okay, so total salary given to these 100 people are 150 lakhs. Okay, so if I'm say working in some company, say Airtel, okay, and I'm getting a salary of 80,000, so I will see opportunity in Reliance that the average salary of Reliance is 1.5. So I can switch there and will get a better package in this Reliance. Okay, maybe around 1.2 or 1.8, anything around 1.5 I can get. So something above 80,000. Okay, but I'm going to add one more person salary to this figure. In that case, just Mukesh Ambani, okay, who might be getting 100 lakh salary, okay. So if I'm going to calculate the average now, so this person is getting 100 lakh. So total salary given to all the employees of Reliance will be 250, right? So now if I'm going to calculate this average now, so what will happen? Divided by 101. So now the average salary of this is coming 2.5, right? 2.47, so 2.5 lakhs. So now person working in Apple may be thinking that I am getting 1.8 here. So if I will switch to Reliance, I might be getting around 2.5. So this will be a very disastrous conclusion made by him, because this data actually contains one outlier. Okay, so only inclusion of one outlier is actually disfiguring the average completely and not giving the true characteristic of the data, right? So whenever there is an outlier in the data set which we are using for observation, we cannot use mean as a measure of central tendency. In that case, then we can use median or mode. So basically we use median. Okay, so let's see what is median then. Just say I'm pulling out here 10 data or 11 data points. Yeah, just say I'm going to put any random number over here. Okay. So when we talk about median, so this is n, the number of observations, and this is the observation actually. So when we need to calculate the median, the formula for this is n plus 1 by 2. Okay, so if we are going to calculate here, so n is 11, 11 plus 1 is equal to 12 divided by 2, that will be 6. So basically in median what happened that we have to reach such a position where number of observations below this will be equal to the number of observation above that. Okay, so this is projection. Okay, so the observation adjacent to this position is going to be median, but after we arrange these observations in either ascending or descending order. I'm just sorting it according in ascending order. Okay, so in front of sixth position, what is coming 54. So you can see the number of observations having value below 54 are exactly same in number, that is 5, will be equal to the number of observation having value higher than this median is equal. Okay, so this is exactly in the between. So this is the measure of central tendency. So suppose if I am going to use the Excel function for this, it will give the same 54 as a median. Okay. And for mode, so mode as I already told you that the observation which will be having highest frequency is the mode. So in this, the highest frequency is for 54, right? It is repeated 3 times. So mode will be 54. Let's put it in the Excel. So mode is 54, right? Now let's look for this data. Median will be so the median is this and mode is so mode is 371. Okay, so we are done with mean, median and mode, and we also understand when and where to use mean and median and mode. So this is just the summation of all those things which I just explained, that in case of qualitative analysis we can use central tendency, and dispersion we are going to talk about it later. And when we are using quantitative analysis and there is no outlier in the data, then we can use mean as central tendency and standard deviation as measure of dispersion. But if we are in quantitative analysis and the data will be having outlier or it's skewed either right or left, then we will use median as measure of central tendency and interquartile range. I will discuss it. So interquartile range as a measure of dispersion. So let's understand how we can see that there is outlier in a data. So this is box and vector plot. So this particular thing is the box, and a thread kind of thing coming out of his whiskers. So here in exactly in the between, it is going to be the median, which we have already calculated. Okay, this is also called quartile 2. So what is quartile? Quartile is dividing the entire data into 4 equal parts. Okay, in terms of position, as I discussed about the median. Okay, so what is the observation at 25th position? What is the observation at exactly 50th position, you can say, and what is the observation at 75th observation? So median is the Q2, quartile 2. The left end of the box is Q1, that is quartile 1, and the right end of the box is Q3. And this line at the end of this curve are maximum and minimum value. Okay, so maximum and minimum value we can calculate in 2 ways actually to consider the outlier. Okay, so if we are going to first, let's calculate the data, okay, required for this. So we need Q1 and Q2, right? Let's first calculate quartile 1. Quartile 1, the function for it is quartile. Then select the data, and then first quartile, so put 1, and then the Q1 is this, right? And then quartile 2 will be this is going to be quartile 3. Okay, quartile 2 is the median. So this is the Q1 and this is Q3. Okay, so now we are ready with the, okay, so we also need a maximum and minimum value. So maximum value is going to be this, and minimum value so these two are maximum and minimum value. So if we need to calculate interquartile range, so the formula for this is Q3 minus Q1. And formula for range, okay, so here we are going to calculate the range. So this is going to be maximum minus minimum. Yeah, I'm just coming to quartile 3 once again. So quartile 3 is formula for this is just quartile, selecting the data, and then 3. So here we are going quartile 3. So basically it's like if this is a number line, okay, I'm going to divide the whole data into 4 equal parts. Okay, so this is exactly, suppose there are 100 data, 101 data, 100 data, just take 101, so 50 will be exactly the middle one. So this is going to be the median, okay, and after that, this is going to be the Q3, okay, and this is going to be the Q2. So here the 25% of data will fall in this region, 50% of data is going to fall in this region. This region will contain, the whole this region will contain 75% of data, and the whole of course is going to contain the 100% of data. So basically quartile divide the data into 4 equal parts, and this is going to be Q3 and Q2. So I hope I made it clear. So now see how we are going to plot the data for box and with plot. So here I am going to draw this box, and these are the risk scores. So here and exactly median will be here. So I just forgot what we calculated as median. Let's say that the median was, I think, 356. Okay, and this is going to be quartile 1. So this here, sorry, here Q1 will be here. So it is going to be 340. Quartile 3, that is this, will be in this end, 370. And maximum value is 435. And minimum value is 389. So basically what we are going to do now is see that this data is containing some outliers and all. So to calculate this, we need to multiply this value with 1.5. Okay, so we will get some value between these two figures somewhere here. So this will be my a point. Any data line outside this will be considered as outlier on the higher side. In the same way, if we are going to multiply 340 with 1.5 and then subtract this, then we will be somewhere here. Okay, so this is the lower side data point, below which the observations will be, it will be the outliers on the lower side. Okay, this is how we come up with the outlier. We try to identify that yes, what is the outlier. So all the formulas over here are mentioned. You can see this, how to calculate this vectors over here. Either it will be the maximum value Q3 plus 1.5 multiplied by IQR also we can use. Okay, so let's so instead of directly multiplying it with the quartiles, we can also use IQR, interquartile range. So we will multiply this with 1.5 and then add it to the Q3 and Q1 again IQR multiplied by 1.5 and subtracted from Q1. So we will be getting a data. For example, multiplied by 1.5. So this is the data, right? So the lower limit will be, let's calculate it over here, this minus this, and the upper value will be this plus this. Okay, so if we are going to see our maximum minimum, our maximum is 435. Okay, but according to the statistics, okay, the value should be under this 416. Any value outside this will be considered as an outlier. Okay, so few data points will be having value above 460, that will be considered as an outlier. Okay, and value below 295. So there are few values which is as low as 289. So it will be counted as outlier in the negative side. Okay, so this is how we come up with the Boston Whisker plot. Okay, so now let's go to next topic. So we have already discussed about quartile, interquartile, range. So now we will discuss about the standard deviation and variation. So what is standard deviation? Let's try to understand that mathematically first. So what we do, we need the mean of this data. Okay, so first we will calculate the average. So average of these data is, as we have calculated, is 356. Now what we are going to do, we are going to calculate the distance of each data point. Okay, distance of each data point from its mean. Okay, so let's calculate it. So this minus the average. Let's fix this. We have fixed this because mean is the same, data point will only change. So now when we will expand it, these are the figures we are getting, okay. And when we are going to sum it up, okay, this will come somewhere near 0, a very small value or exactly 0. Okay, so value is 2 point, it's very negligible number, right? It's e minus 12. So it's basically a very, very negligible number, right? So just consider that it is a 0, okay. So actually what is standard deviation? The standard deviation is the average of the distance of each data point from its mean. Okay, so if we are going to calculate the average of these distances, then it is going to be the standard deviation mathematically. But the problem is there are some negative data and there are some positive data, and that is going to add up as 0. So if the whole sum is going to be 0, and then we are going to divide it by the number of observations, the outcome will be 0, right? So in this way we cannot get a standard deviation. So to get the standard deviation, what we are going to do, we have to eliminate this negative. Okay. So for this we will square these numbers. Okay. So the square will eliminate the negative. Okay. And of course the value will increase. So now we are going to do this for the whole set of data, and then we are going to calculate the sum of it. Okay. Now when this sum is going to be divided by the number of observations, we are going to get a data which is called variance. Let's calculate it. This divided by number of observations. So we are going to have 250 observations. Okay, so the variance is 713. So this is called variance. Okay. So as we have squared it over here, so this is the squared value, right? So now if we are going to calculate the square root of it, then what is we are getting is the standard deviation. So let's calculate it through Excel formula or function. So variance is going to be variance of this data is going to be I'm sorry, I calculated the wrong variance over here. So this is the variance we are getting, right? And if we are going to calculate the standard deviation, of the standard deviation of the data, so you can see that the function of the Excel as well as our manual calculation is giving exactly the same result. So I think that you are able to understand the difference between variance and standard deviation and how they are calculated. And now let's talk about their significance. So if I am saying that, so this, let's talk on this figure. So this is the standard deviation of this stock price, right? So what does it say? That if I am going to buy this share, okay, the average risk I am going to have. So average price is 356. Okay. So under most probable condition, the share price will be somewhere between these two figures. Okay, the share will be between these two figures. That is, the share price can, just a second. So share price will be, I was discussing, yeah. So basically the share price under most probable condition is going to be between these two data points. So today if I am going to buy a share with this price, I can need to be prepared to get loss of around this amount. Okay, so that is my risk associated with this share, or I can also gain up to this price. Okay, so basically this is what the risk it shows. For example, if I say that any other stock having a standard deviation of 50, it means that the share price can go as high as this and as low as this. So higher standard deviation means higher risk, right? So share I can experience higher loss in this kind of share having higher standard deviation. Okay. So if a share giving whose expected return is say 10%, if I have two shares A and B, and in a year I can expect that both shares going to give me 20%. Okay, but their standard deviation is different, their risk is different, like 26 and 50. So I will always go with the share with a standard deviation of 26 because it is assumed to having lower risk. So I hope you are able to understand what is standard deviation and what is the use of it. And the same way, variance. Tell us, higher the variance, higher the risk, lower the variance. The only difference between these two, variance and the standard deviation, is the square root. Okay, so basically we use standard deviation as measure of risk. So I hope I made things clear. So let's stop over here for this session. Correlation and coefficient, we need to have another set of data for that. So we'll discuss that in the next session on next weekend. Next weekend, not tomorrow. Tomorrow is going to have a session 2 and maybe on Sunday the session 3. So we will meet again over there. So, now if you have any confusion, you can ask questions. Is there any confusion till now what we have covered? Well, I hope that all things are okay then. Tomorrow we will get the link for the class and we will discuss the probability theory tomorrow and learn about the probabilities and the theories related to that. Okay. So I hope we are done for today and thank you very much.